So cool. If you'll pardon the pun, my talk's called The Bridge to JSI because the current architecture is called The Bridge, as many of you all know. And the new architecture, which hopefully some of you have heard of, but maybe there's not so much awareness, is this concept of the JSI. So I'm an architect developer at Theodo UK. Just recently became an architect. And so sort of on a daily basis, I work with React and React Native on a multitude of projects. So yeah, I've been asked to come and share something interesting that I know about React Native. So I actually had, I presume, similar to many people, kind of an unorthodox introduction to computer science. I was not originally a computer scientist, I was a physicist. My first exposure to computer science actually comes from my dad, who has a PhD in computer science. And he came into my room one evening whilst I was, at the end of my first year of physics, I think, and he said, "I can explain everything." He came in with a piece of paper and he said, "I can explain everything within an hour." So 3 hours later, we were still discussing bits and bytes, and I had next to no idea what was going on still. So I suppose, fortunately, I stuck with it. And he took a step back and he instead tried to teach me a bit about programming rather than CS. And I kind of got into Java, writing the basic text-based games. And then the next progression for me was moving on to writing native Android applications. So this was something that I wrote many years ago now. And it's a peer-to-peer study session organizer for students. So essentially, you can message other students, figure out what their what skills they have, and you can organize peer learning sessions. But obviously, native Android is quite a steep learning experience, and you deal with a lot of low-level stuff. For example, it's all imperative programming. So I searched this repository and found 88 instances of find view by ID. It's not what I want to be dealing with. I want to be dealing with business logic. So I joined Theodo and discovered React, and I was like, this is great. I've got my declarative syntax, which is JSX, and I don't need to deal with all of this low-level programming of the UI. And obviously with learning React, it comes with a low barrier to entry for React Native. So web developers can quite easily just jump into React Native without much extra any extra sort of level of expertise. You can kind of start developing in React Native straight off. And so I think it's important to kind of share well, what is React Native? Because quite a few people in here I know are React or web-based developers. And I want to explain what is the current architecture, how does it actually work, and what sort of a high-level overview of what's going on, just to prove to you that it's not magic. It can seem like that at certain points. And then Facebook have actually been working on this concept of a new architecture, which is relates to the JSI, which I want to discuss and hopefully bring or raise your awareness on this. So step one, what is React Native? So React-based applications have two parts. You've got a React, the actual React library, and this purely deals with reconciliation. This process called reconciliation, which is essentially taking your functional components and building up this thing called the virtual DOM or the shadow tree. but it has actually nothing to do with rendering. The second part of React-based applications is you've got a renderer which actually takes that that virtual DOM and decides like, what do I need to do to actually like render this to the page. So like if we look at the sort of typical create React app web application, this is kind of what you'll see in the index.js. Obviously, for like a single page web application, you receive some index.html. It has a root element, and then it will run something like this. So we've got actually like the React library. So we've got we're importing some app. We've got a functional component, and we've got a JSX syntax. And then the second part of this is like actually the thing that's rendering your app to the screen. And in most cases for, well, maybe not in most cases, but create React app, you'll probably use React DOM.render to actually render this to the screen. So what does a React Native project look like? Very similar. This will be your like app. Well, not your app.tsx, but your like index. You've essentially got the same thing. You've got React. So everything that I can do in React, I can do in React Native. But here, the things that we've switched out is essentially the renderer, which we're getting from React Native. You've got the app registry, and you're saying register this component, and you give it the root name of like the app essentially, and this goes and then finds the root component, which is somewhere in a native view, and it knows now to render that React element tree to your root view. So to summarize, React Native is a renderer for React. It's not doing anything magic. We pass it a virtual DOM. In React Native world, we kind of like to call this the shadow tree as well because it sounds cooler. And React Native decides which native components to show. So I suppose it's important to note we are actually rendering like real native components exactly as they would be rendered on a sort of regular native project. So this is what we've got at the minute. You've got your like native device, and what React Native brings to this is a JavaScript engine. In this case, it's JavaScript core. It comes with iOS, and they bundle it in with your Android application. And this has well, I don't want to say like a nice C API, but like you can interact with this through a C-based API, which comes with the VM. And then essentially on that engine, you're running your React application. And this just deals with like the reconciliation and the business logic. So exactly how you would expect to use React as a web developer. And then you have this like second side of things, which is the native project. So this is in Java or Kotlin, and for iOS, it'll be Swift or Objective-C. And that, along with the help of React Native, like the React Native library, that deals with the rendering of the UI. So just to zoom in a bit on the native side of things, I assume you guys, some people will be familiar with this directory structure. I hope so, at a React Native meetup. Essentially, you've got your source folder, which is all of your source code. And you also have an Android and an iOS folder in your React Native directory structure. And just to demystify it, this is exactly the same as any native, like any native application that you might make. So anyone who's familiar with native Android development, so this will be me like 5 years ago, will be familiar with this kind of structure. So just taking a quick look inside the main application, the important thing here is just a regular main application. And we're importing some of these things from a place called com.facebook.react application. So a lot of the abstractions are actually coming from the React Native library. But something that you might notice if you've had a look around your native project is there is no place in your actual native project called com.facebook.react. Does anyone know whereabouts this actually lives, this code? Getting some shaking heads. Okay, well, yeah. The secret is it's in your node modules. So obviously every React Native project that you create, well, you'll use like npm or yarn to like get the dependencies, but like the React Native source code is in your node modules, and React Native uses something called auto linking to like link the native projects that are stored inside your node modules to your actual like main application. So you can actually go digging around in the React Native source code to see what's going on. So we're kind of missing something in this picture, and it was alluded to in the previous presentation. But how do we actually, how does the JavaScript engine actually communicate with the native layer? And I think lots of people will be familiar with the concept of the bridge. But what actually is the bridge? So there's actually this like world of C++ that kind of sits in between your native project and the JS core VM. And this is where the bridge lives. And essentially all the bridge is an async batched message queue. It sounds scary, but essentially all that's happening is every time that your React application wants to communicate with your native application, it just like JSON serializes the message, batches those up, and then sends them across the bridge. So this means it's all like asynchronous. Once like your React application sends a message across, that's it, it's gone into the ether, and it expects that your native project is going to just pick that up and respond by rendering it. And actually in practice, it's split up into two sections, possibly in implementation detail. You've got the native to JS bridge and the JS to native bridge. And on the side of the native project, this is where your like native root view will live. You also have this idea of a bridge interface on the native side. So all of the interactions between the bridge kind of go through the bridge interface on the native side. And then obviously on the native side of things, you've got all the core modules that come with React Native. So that's everything in the React Native library, plus any custom native modules that you write yourself. So you can actually go into that Android folder or iOS folder, write some native code, register that as a module, and use the bridge to communicate between your React application and your custom native modules. So let's just, for the sake of demonstration, show what happens when you press a button, for example. So we're responding to a click event. Now this obviously originates on the native side of things. We're rendering native components. So the click event happens natively somewhere underneath the root view, which communicates to the bridge interface. And that gets sent along the native to JS bridge, which your React application then picks up. And it does some business logic and very simply sends back the response of whatever UI update, whatever update to the React element tree has occurred. So like the diff between the two trees goes back to the bridge interface. And at this point, React Native is deciding how to render this, and it re-renders like all of the changes that you've like that are the side effects of the click event. Cool. And it's just worth noting that this all on the left-hand side is all cross-platform. Anything that involves Java or Swift they need to write a unique implementation for iOS and Android. And currently, the renderer kind of lives on the native side. Yeah, and this is like not, it's not magic. Like someone wrote this code, you can go and see it and like see what's actually happening. So the good things about the bridge, it's asynchronous. So it's not going to block my UI thread, like waiting for synchronous events. Another really cool thing is that it's decoupled. So as long as you follow the React bridge like command interface, you can use the React Native bridge to render native components because it is just a renderer. And so I've seen online people creating almost like Angular native, where they've connected, they've created an interface for like Angular apps, which then uses the bridge to then render their components, which is pretty cool. But obviously, there are some cons to the bridge. So we've got a lot of duplicate implementation with things being implemented like once on the native Android side and once on the native iOS side. And also, we have no way of like having any synchronous events. Like the JavaScript environment has like no way of knowing what's actually going on in the native thread because it's just sending messages. And this means that there's like no way to prioritize like UI events for as an example. So very famously, there's the issue with like scrolling flat lists. All of these updates have the same like level of prioritization in terms of UI. So there's no way of like interrupting an animation, for example. Yeah. So moving on to the new architecture, how is this going to change? Well, it all revolves around this idea of the JavaScript interface. And what does that actually mean? So has anyone tried just taking a step back and moving back to web development? Has anyone tried like printing out the value of console.log in their, like when they're inspecting on Chrome? And does anyone know what it prints out? Yeah, exactly. So we see this. We've got, it prints out the implementation, which is a function called log, and it says native code, which seems a bit, I don't know, obscure. But essentially, and I'm not sure how many people know this, like the ECMAScript specification hasn't got any mention of like console. So console is actually part of the web API. So all of your browsers will, well, depending on which browser you use. So each browser implements differently the implementation of console. So obviously all of them by convention have the console.log, but the JavaScript environment where you're actually like logging out console.log has no understanding of like the implementation details that are gonna go on when you do console.log. It just has a reference to the function that it needs to run on the native side of your device. So essentially console.log, it's running some native code. So it's not running JavaScript when you actually run your console.log. But you can call it from JavaScript. And that's essentially analogous to what the JSI is going to be doing. So previously we had this idea of the bridge, but that is going to be replaced by this idea of the JSI, so the JavaScript interface. And essentially, we're no longer tied to one specific JavaScript VM. The reason being that this is its own API, and all of the communication that happens between the React application and the C++ side of things is now going to go through the JSI. And obviously this means, we discussed Hermes a bit before, which is a new JavaScript engine, which is optimized for React Native. And I think React Native are going to be pushing this a lot more with the JSI, like as they move more towards using the JSI and away from the bridge. But this is what React Native say about the JavaScript interface. It's essentially a lightweight API which allows you to embed a JavaScript engine into a C++ application. Yeah, so exactly what I've just said. It allows you to interface between JavaScript and C++. So your JS and native, so native is now, when I say native, C++, are actually aware of each other. So you're going to be able to call functions, native functions directly from JS and vice versa. And what this means is, because we're no longer sending this, like sending a message across the bridge, we now have like synchronous events. Like you can just call a function exactly as you would as if it was JavaScript, like kind of in the same thread. I've discussed that it's decoupled from the JS engine because everything's going through the JSI. It should be able to switch out the actual engine that you're using. And another thing is, like, React Native is obviously like write once, use everywhere, or whatever. But more of the implementation is moving to C++, which is cross-platform, which means that any optimizations that are made for Android or iOS, both platforms are now getting those optimizations. And also C++ is a very optimized language as well. So we've got the JSI, but how, obviously we're now actually talking between your React application and the world of C++, but JavaScript and C++ are very different languages. You've got JavaScript, which is a dynamically typed language, whereas C++ is statically typed. So Facebook are actually doing something quite nice for us. They're going to be introducing this utility called CodeGen, which essentially is going to help us integrate static typing between TypeScript and C++. You can also use Flow, but essentially what this is going to do is, like, if you're writing a native module now, CodeGen is going to be this tool which will allow you to generate a lot of the boilerplate code, a lot of the interfaces, and it bases that off TypeScript. So TypeScript can be your source of truth if you're ever sort of delving into the native world yourself. So we've now got the JSI and CodeGen acting as a sort of interface between the world of C++. But Facebook are actually also moving the renderer to this world of C++. And we mentioned it before. So if anyone was wondering what Fabric is, spoiler alert. So what this is doing is it's taking the React element tree that we pass it in some of those first slides, and it transforms that into the shadow tree. And it does a load of layout calculations. This is kind of what the renderer is doing. It uses a library from React Native called Yoga to do those calculations. Obviously, in the web, when we're actually like writing our React Native, our React code, we're in the world of Flexbox, but that doesn't really exist in the native world. So we can, instead of like using Flexbox, we've got Yoga to calculate where things are going to live on the screen. We also do this thing called view flattening, again related to the fact that we use Flexbox on the web. This was initially an optimization that they made for Android, but one of the nice things here is that as we move to a shared implementation, a lot of the optimizations that we get for one platform is shared with the other platform. So essentially what we're saying with view flattening is quite often in like HTML or JSX, you have a lot of, you use the box model on the web essentially, and this leads to like lots of nested views. And because these views are just no longer needed, React Native gets rid of all of the intermediate boxes that you're using. And this just optimizes so you're not like rendering loads of views which are nested. And only when we get to the actual mounting, like the promotion of from the old host view tree to the new host view tree, does the native side actually step in, and then we promote, we promote the tree to being the live tree. And this is called Fabric. And Facebook have been working on this for like 4 years at least now. Cool. So as I've discussed, consistency between the two platforms. We've got performance gains of everything being in C++, and any performance gains from one platform, like optimizations that we would make from one platform, get shared with either platform. Obviously, because everything is synchronous now, we can deal with prioritization of UI events and actually like interrupting UI events. So for example, if you've got an animation, you need to like interrupt that animation because a new animation is happening. You can actually do that. And another cool thing that is shared across actually all things that use the JSI is they kind of boast a faster startup time, like application startup time, because all of your native modules are lazy loaded, which is pretty cool. And not only do you get Fabric, but also you get this new thing called turbo modules, which takes into account any native, like custom native modules that you might want to write. So say you want to implement something in C++, or on the native side, or you're trying to optimize some code and you decide, okay, I want to write this in C++ rather than JavaScript. I'm just going to delve into the world of C++ for a bit. You can write a turbo module, and this is kind of the rebranding of native modules. But essentially, it allows you to gain access to native functionality directly from JavaScript, because obviously through the JSI, my JavaScript actually can call native code synchronously. What this will kind of look like is you'll have like a turbo module proxy at the global level, and you'll be able to like pick out your specific module and then just import that in JavaScript as normal. And under the hood, it's calls native function. So this is the promise from Facebook. 2022 is going to be the year of the new architecture. They promised us that in 2018 as well, but it's going to be the year because it all exists. So you can actually go into your node modules and you'll see these things. You'll see the JSI, you'll see the new renderer, and people have been using it. So this is the React Native directory. Okay, quite a crude search, but 7 people have specifically said in their React Native module that it uses the JSI. But I mean, this is not everyone that's just using the new renderer. So this is an example. There's a library called mmkv, which someone made. And they're comparing this. This is essentially an alternative to async storage. So they've got this comparison where they're reading a value from storage like 1,000 times. And look, it's so much faster, which is good. And they claim it's like 30 times faster than the default async storage, which is really cool. And I suppose one of the reasons that that will be is there's no like batching of events that you would need to do over the bridge, because you're actually just directly calling your native function. There's another library here, SQLite at native speed. So they boast 2 to 3 times faster, which is not quite as good as the 30 times faster of the previous library. And then also Reanimated as well have essentially rethought their entire library. They've got Reanimated 2, which like changes the API completely. So yeah, people are using this. Oh, the caution is this is experimental, and your dev experience may not be as good as it will be in the future. But you can definitely start implementing your own like native modules or turbo modules using the JSI. The only thing is you might not have as fun a time. But I suppose it's quite an exciting time, because there are lots of modules out there to be optimized. So we had the SQLite, which I presume someone has just been like, cool, there's this new thing, the JSI. I wonder if it makes it any faster. So yeah. So to summarize, what is React Native? It's a renderer for React. And it essentially produces physically a native project for you that uses the utilities from React Native to render your application. The bridge is the current architecture, so it connects native to JS via like JSON, a JSON message queue. And then the important things that you guys should know from the new architecture is that everything is based on the JavaScript interface, which allows JavaScript and C++ to invoke each other synchronously. The new renderer is called Fabric, which is implemented in C++. And we've got CodeGen as well, which will hopefully make our lives a lot easier when we're looking to implement our own native turbo modules. Cool. Any questions?